So we've at least looked at some informal methods to see if an argument is a good one. But, you know, there are a few problems with these, and one of them just is, it's like, well, maybe we can see that it's really bad, but if it's a good argument, how good is it? There's a lot of subjectivity here, right? That's why we call it informal. It's going to be not exactly precise, it's going to be unclear sometimes. And to deal with that is why we start talking about formal logic. We're going to be able to say precisely whether arguments satisfy certain criteria, and if they don't, at least for some arguments, that's going to be a way of showing that they're not, in fact, good arguments. Now, the first of these we're going to talk about are deductive arguments and this concept of validity. Now, validity is only a concept that applies to deductive arguments. Not all arguments are deductive. There are at least one other kind of argument, inductive arguments. And a lot of philosophers, myself included, think that there's probably another type on top of that, abductive arguments. We're only going to talk about deductive arguments and maybe inductive arguments if we have time. Why not talk about abductive arguments if they exist? Well, are they not important? Well, actually, I think they're very important. But the reason is there's no precise method for evaluating them. There are very precise very clear, you could even say mathematical methods for evaluating deductive and inductive arguments. So we'll talk about deductive, and we may, I hope at least we will get into inductive. We will see. But, why don't we talk about abductive? There's just no good formal methods that have been invented for evaluating them. People have been trying for various reasons. This would be a huge, huge thing, but there just aren't. Van Cleve says there's no agreed on methods to evaluate inductive arguments. I don't know why he says that because it's just not true. There are some, and we will talk about them. They're more complicated than the deductive ones, but they do exist. All right, so let's take a step back from all that, though. And I want to start by talking about this concept of validity. And, look, I know in ordinary day to day speech, if you say valid, you might just mean good or convincing or whatever. I am not the language police. Do not picture me over your shoulder saying, that's wrong. You can never use that term in that way. But I do want to tell you that is not the way we use the term in logic. Generally speaking, philosophers won't use it. They'll use it the way that we do in logic. Doesn't mean that that's, God on heaven has dictated how you use this word. But when we use it, it is very helpful to pick out a very specific concept. Fine if you want to use validity in other ways outside of this class. Knock yourself out. Even if I heard you do it, it wouldn't annoy me. But just know that we're going to use it to mean something very, very precise in this class that doesn't exactly hook up with the normal day-to-day meaning of this term. Okay. So sorry to bang the table on that, but that's actually pretty important. So what do we mean by validity in philosophy and logic? If you take math, they'll also fall back on this concept of validity a lot too. What do we mean by it? Well, when we say an argument is valid, we mean that it is impossible for all the premises to be true and the conclusion false. If all these premises are true, the conclusion must be true as well. Now, I'll give you guys some examples, but I do want to tell you that validity is a very, very tricky concept. People have trouble with this. It is not a natural way to think. For whatever reason, the human brain is not wired to think in these terms. Doesn't mean you can't do it. It just means that it's a little hard to start with, a little artificial, and a lot of people have trouble with it. If you have trouble with the concept, you are not alone. Hopefully, once we look at some examples and talk about, work through some cases, what validity is will be clear. But just keep in mind, it is tricky. People have trouble with it. Take two things from that, right? One is, if you have trouble with it, don't beat yourself up. Don't get discouraged. It is very, very, very common. More people have trouble with it than not. Two, be very, very careful with it and do practice and do make sure that you get this concept down. Okay, so having said that, let's get into what we mean by it. Well, Van Cleve gives us a few intuitive cases, and I think to start with, these are perfectly fine. So, I won't use his examples, but he just says, well, look, can you imagine a case where the premises are true and the conclusion is false? Can you imagine that? Here's one for math. 2 is a prime number, so not all prime numbers are odd, right? Can you imagine a case where all prime numbers are odd and 2 is a prime number? No, because if you remember, I don't know, high school, elementary school math, if you remember your math from school, you know that 2 is a prime number, right? Or sorry, you know that 2 is an even number, and you know that even numbers are not odd numbers. This premise cannot be true and the conclusion false. This is, in fact, a valid argument. Donald Trump is president, so he has to be 35 or older. Is this a valid argument? Yes. To be president, you have to be 35 or older. It's in the Constitution, if you remember your high school civics, or I don't know, maybe it was middle school civics, but if you remember that, one of the requirements to be president is that you are at least 35 years old. So anyone who's president is at least 35. Now, you might want to get really hair splitty on this and, say, well, what if somebody lied about their age, Jimmy James is actually 33, but he's fooled everybody and he's president. Just people don't know that he's falsified, whatever. Look, we will talk about this. One of the things with validity, with deductive logic, with formal logic generally, is to be very, very precise to an annoying degree. So yeah, if we wanted to be really precise, we would say, was legally elected president of the U.S. this hypothetical Jimmy James, if he existed and he's 33, maybe he could fool us, but he wouldn't legally be elected. He would be breaking the law, right? Anyway, leave that aside for now. I hope this is intuitively clear. But if you want to be really, really hair-splitting about this, well, yeah, you do need to be more precise. And quite honestly, getting in the habit of being more hair-splitting, at least for formal logic, especially deductive logic, is not a bad thing. All right. Here is one more. The Tigers beat the White Sox last night. I checked, they did. The White Sox, as of this recording, are terrible. They were really bad last year. They seem not to have improved a great deal, right? Tigers beat them last night, so the Tigers must have scored more runs than the White Sox. Now I want you guys to notice, it is in fact true the Tigers beat the White Sox. It is in fact true they scored more runs. But is this valid? Is there a case where the premises are true and the conclusion is false? Well, yeah, there is. The normal way to win a baseball game is to score more points than the other team. But it is at least possible, it's happened a few times, where a major league team will forfeit if the team you're going to play forfeits, you win. You didn't score more runs because nobody scored any runs, right? A few different ways to forfeit. Um, I think if some team just doesn't show up for some reason, they forfeit. I'm not sure that's ever happened in Major League Baseball. The most common way to forfeit in Major League Baseball is if your fans riot. If your fans riot and it's dangerous to take the field or impossible, you lose. I don't know who the last team to lose this way was. I know it happened a few years ago. I know that for years and years, the poor White Sox were the last team to lose because their fans rioted. Disco Demolition Night, we won't get into it, you can Google it. All which is to say, though, this is not valid because there are other ways to win a baseball game. You can at least imagine that, you know, one team wins by forfeiting. It's at least possible. Even if it had never happened, even if that was just a rule and it never has happened, that would be a way to do it. This would not be a valid argument. Van Cleve talks about, Gerald Ford was president, so he must have been elected president or vice president. He was the first person to ever become president who hadn't been. But even before Gerald Ford did that, if you looked at the Constitution, it was at least possible for somebody not elected to either office to become president, right? If something happens to the president and vice president, it's in the Constitution, Speaker of the House becomes president. That's never happened. It was always a possibility, even before Gerald Ford came on the scene. This was never a valid argument because there was always a way to become president without being elected to either office. There are several ways, right? In the same way, even if no Major League Baseball team had ever forfeited, even if the White Sox idiot fans had not rioted, well, it is still a way to lose a game, so this argument's not valid because you can imagine a way. Sorry. Van Cleve talking about Gerald Ford got me in the mind of politics, so whatever, I've been prompted. My examples are going to fall back on politics, but whatever, right? If you don't like them, come up with your own. If you don't like baseball, well, think of another sport too, right? So here is another argument. The majority of Americans voted for Ronald Reagan in 1984. Lifelong Republicans were even more likely to vote for Reagan than the average American. Robert is a lifelong Republican, so Robert voted for Reagan in 84. Is that a valid argument? Well, look. One thing I'm going to tell you guys, when you see an argument that uses terms like majority, most, probably, then they're almost certainly not valid. We will get to that in a second. This is not valid, right, though, because it could be true that most Americans voted for Reagan. It could be true that Republicans were even more likely to vote for Reagan. Both of those are true. But it could be false that this guy, Robert, is a lifelong Republican and voted against Reagan, right? I actually think of this. I had a great uncle who I think he voted Republican in every election from like 1948 on. He also worked for the state of California. He was a high up bureaucrat. For whatever reason, he personally did not like Reagan when he was governor. I think it's because Reagan never remembered his name and just called him by a nickname anyway. Uncle Robert really disliked him. The only times he ever voted not for Republican were when Reagan ran, right? It is at least possible. This describes my relative who, for whatever reason, did not personally like this guy, right? It is possible. Or, take a slightly more hypothetical and outlandish one. not outlandish. So there are 10 bags of marbles on the table. 7 have all black marbles, 2 all white marbles, and 1 has 8 white marbles, 1 black marble, and 1 green one. You won't get a green marble if you pick a bag at random and grab a marble without looking. Well, is this valid? Well, obviously not, right? It is at least possible. It's unlikely. It is very unlikely that if you pick a random bag and just put your hand in it and grab a marble, that it's going to be green, right? It is, if we manage to get to inductive logic, we'll talk about some techniques for figuring out the odds. But this is literally, 1 in 100, right? It's very unlikely, 99% chance you won't get a green marble. But, if you did this often enough, right? If you, in this setup, picked a bag and a marble, if you did it a million times, not only would you almost certainly get green once, you'd probably get it multiple times, right? It's unlikely, but it is possible to get a green marble, so this is not a valid argument. Well, does that mean that this is a bad argument? What would you say to somebody who said, well, it's at least possible to get a green argument, get a green marble, so, I don't, if I'll offer you a bet, you win $50 if you draw the marble of the color you said. He said, well, doesn't matter if I pick black, white, or green, so I'll just pick green because it's at least possible to get green. Is he reasoning well, right? No, he should bet on black. Why? Because there's slightly more black marbles than any other color. If he doesn't want to bet on black, he should bet on white. He certainly shouldn't bet on green, right? It is a good argument if you say you're probably not going to get a green marble, but it's not valid. What does this mean? Well, there are, like I said, there are 2 different types of arguments. Deductive arguments, when they are valid and the premises are true, the conclusion must be true as well. But there are a lot of perfectly good arguments, inductive arguments. If the argument is good, and we'll say a little bit more about what it is for an inductive argument to be good, and premise is true, or at least likely to be true, the conclusion is likely to be true as well. It is very likely if you grab a random marble, it is not going to be green. This is a very good inductive argument. Tigers beat the White Sox last night, so the Tigers almost certainly scored more runs. Well, it's not valid, but it is a very good, it's not valid if you look at it as a deductive argument. But if you're very precise about it and you say certainly or likely, then it is a very good inductive argument. It is incredibly rare that major league teams forfeit. It's possible, but almost all the time when one team wins, they score more runs. If a team wins, you have very good reasons to think they scored more runs, even though it's possible they win without doing that. The same with this argument, right? What I told you about this guy, Robert. If we say he very likely voted for Reagan, that's true. Odds are he did, given everything we know about him. As an inductive argument, this is perfectly fine. Now, one thing in real life that you're going to have to do is to decide, do I interpret this as an inductive argument or a deductive one? Well, remember the principle of charity. You want to give the other person a good argument. So keep that in mind. If you're being precise, if you're being, very good about this, I guess I would say. When you have an inductive argument, you'll use words like likely or probably or almost certain or most or the vast majority or things like that just to indicate that it is inductive. But people are sometimes sloppy. When people are sloppy, you have to decide, is it inductive or not? Or is it deductive? Now, here's one thing I'll say. Sometimes students will, because there's always a risk with inductive arguments, they'll think they're kind of inferior to deductive arguments. That's not true. A lot of times a deductive argument will give you very good reasons to believe something. And look, most of the time when you reason in day-to-day life, you will use inductive arguments, right? You know, let's say that I have a friend who's a very good cook. I've been to his house a dozen times and dinner's always been delicious. He invites me over to dinner and my wife's like, well, should we go? And I'm like, well, the food's always been great. So it'll probably be great tonight. And she'll be like, that's invalid. We don't know. No, we do know. It's very good reason to think you're going to have a good meal, right? On the other hand, if somebody invites you and their food is always awful, they can't cook, you're like, I've never known him to make a good meal. Well, that's not valid. You say, well, it's possible that in the last 2 weeks he's learned to cook. He's taken a course on cooking. That's possible. Let's go over and eat. No. If every time you've eaten this person's cooking, it's been terrible, it's probably going to be terrible the next time, right? My point here is this. Most day-to-day reasoning is inductive, and it works pretty well. I would actually say that deductive reasoning is more than a little artificial. We'll talk about how that is, and it is overly cautious. If I say to you something is 99.99% likely to happen, well, that's probably an inductive argument. You can't very well say, well, I don't have any good reason to think that's going to happen, or I don't know. You do, right? You don't need, in most cases, the level of certainty deductive reasoning offers, and honestly, it's often more than a bit stupid to ask for it. Well, then why do we learn about deductive reasoning? For one thing, deductive arguments are easier to evaluate than inductive ones, so I think they're a good place to start. Deductive arguments are either valid or they are not. It is a 1 or 0 thing. On, off, 1 or 0, yes or no, valid or not. Inductive arguments, on the other hand, come on a spectrum from very bad to very good. Because of that, it's just harder to evaluate. If your options are yes or no, 0 or 1, well, that's a lot easier than if your options are really bad to really excellent, or to put it another way, 0% to 100%, where you obviously have more options. That makes things harder. All right, but it's easier to evaluate deductive arguments than inductive, so they're a good place to start. I also think both with inductive and deductive arguments, argument structure is going to be really the key idea. And because deductive arguments are easier to evaluate, we're going to be able to better start seeing what the argument structure is and what we mean by that. And also, some of the tools that we're going to get when we talk about deductive arguments, things like Venn diagrams, which we're going to start talking about even next week, Euler diagrams, which are going to come up, and truth tables, they are all, they don't mean anything to you yet, but they will. All of these things will be helpful when it comes time to evaluate inductive arguments. So even though deductive reasoning is, I think, a little artificial and we don't use it a whole lot in everyday life, it is a good place to start. Okay, so next lecture we'll get a bit more deeply, though, into this concept of validity, what we mean by it, and we'll start talking about some of the reasons that it's actually pretty tricky.